geometrical dimension and tolerance GDNT. See here we have so many things are there in GDNT. Actually GDNT is your language. With the help of that one we can explain the production team how to manufacture your component. Okay, so the manufacturer team, see, initially what happens means each and every information you have to document on the sheets. Like for example, if you are creating a hole and multiple holes are there, those holes are for example concentric. So each and every hole are concentric to specify in a note that those holes are concentric. Those holes are like the distances. Those center must be like that. Everything you have to mention in text in your document for giving the information to the production team. But it is making very difficulty for designers to keep all the information in the text format. So that's the reason what they have. That means they introduce a symbolic language which we which the design engineer represent on the document or on the drawing, and the production engineer will also understand the thing. Why? Because everything is common here. So here we are following so many standards are there, like different companies standard follow different standards. So based on that standard only they will follow, they will give the symbols the drawing areas. Okay, so many symbols are there. For example, I will take an example of flatness. So for example, I want to say that this surface should be flat. How much flatness here? If you are doing manufacturing process now, it is not mandatory that when you are doing the machining operation or when you are manufacturing anything, so what happened, we can't say that the object will get exactly precise to our actual size of the object. We can't say like that. There must be the deviations in every component. So those to avoid those deviations, to avoid those deviations and to maintain those deviations under the limit. Okay, those deviations we have to keep under the limit only. For that purpose only we have to represent these things. Okay, for example, I am getting the deviation of 0.5 mm. But when you are placing the component in assembly, at the time what happened, 0.5 mm gap is very big there. I want to keep the deviation of 0.1 mm. So in that case what they will do, they will remove 0.4 material from the object so that it should exactly fit object. For example, see here I am taking two components out there. One is hole and another is shaft. Okay, one is hole and another one is shaft here. For example, this is my hole and this should be lying like this. This is my hole. Example I am taking here. And here I have to place a shaft here. So when we are placing a shaft in a particular hole, the diameter of this hole is, for example, around I am giving like, for example, 10 mm. 10 mm is the hole diameter, and tolerancing I am giving like, for example, plus or minus. Wait a second, again I'll start back in 2 minutes. Now see here the tolerance will be plus or minus 0.5. Okay, and this is my shaft. For example of the shaft, I am taking like around 10 mm I will take. Just I am taking the tolerance value. This one also I am giving like for example 10 mm plus or minus 0.75 mm. So see here shaft will be this is the tolerance value for the particular shaft, and here I have the hole here. So see here, if I add this 0.5 to the hole, it will become 10. If I remove this tolerance from the hole, it will become 9.5. Like that, the value will become here. Okay, and here if we add this one, it will become 10.75. If we remove it, it will become 9.25. Okay, 9.25 and 3.75 will become here. So like that, the deviation. So see here I am getting the difference of 0.25 here. Okay, we are getting the difference of 5 between those two tolerances. So this shaft will not get fit in under this code. So in that case, how to represent these things? So in that case, what we will do is we will assign some tolerances value. See, same tolerances we will do, but some using some operations and by doing some instructions, we will manage these things. Okay. At the time, we will understand how it will work. Like when we do the inspection, at the time to know that whether this shaft is coming on this hole or not, it is going to fit there or not. See here, for example, if I give here, if I subtract this 0.75 from 10 mm, it will become 9.25, and if we remove 0.5 from it, it will become 9.5. So here, the shaft, whatever it will be, when it is going to fit under this hole line, it will become a loose here. Okay, so like that we have to see and we have to understand the things here. Okay, like this is the basic thing here. So like that we have so many representations. For example, here for this process, what we do, we have to do some machining operations on this shaft to reduce some 0.25 mm thickness or 0.25 mm material we have to remove from this shaft. Okay, 1.25 mm material we have to remove from this shaft here. So in that case, we keep some information on the sheet, drawing sheet. How do we keep information on the drawing sheet? You have to write completely that this much material we have to remove, like that, like that, like that. We have to here. So for that reason, what we'll do is we'll use some surface finish symbol here, so that we can keep. Why? Because we'll do the surface finishing fill the material. So like at the time, we have to understand that these things we have to manage like that. Okay, like that we have to check each and everything, and we have to proceed submission of the drawing. Okay. Okay.
Yes, sir.
So can we continue from Saturday?